All right, my macro friends, we're going to look at economic activity through the lens of a model, and we're going to hit it with a shock. But we're going to do this differently. If you've done this type of training with me before, you know what usually happens is I identify a model, a three or a four equation. You get hit with a shock from the outside. You want to see how that exogenous shock reverberates on economic activity. We're going to do something different. What we're going to do is look at the activity that actually took place in the economy and then figure out what types of shocks could have generated that type of economic activity. We've done this training in class, but we haven't done it yet for this type of homework. So let me walk you through the question. I'll isolate the parts of the template, Excel template, that you should have if you're in my class. And then we'll actually talk about the intuition behind the process. So consider the calibration in the accompanying model template. Again, I'll zoom in and show you the pieces. Assume that all the values for the parameters and exogenous variables other than the shocks explained below are the same at t and t minus 1. So it's ceteris paribus, all else remaining the same. Your task is to find the confluence of shocks that hit the U.S. economy in the year 2024. Now, why 2024? It's the year 2025, so I picked last year. Nothing specific about that. But I didn't say everything. All types of shocks written right there is demand shocks. We could have been hit by supply shocks as well. That's fine. In our particular example, what we're going to do is focus on could a confluence of different types of demand side shocks have generated what we saw in 2024? If you think about it, if we take the reduced form approach that we've been playing with, everything just gets summed up to a single demand shock. We are going to look at a structural model. So the demand shock could actually manifest in lots of different ways. And we could think of it like we are scientists, social scientists, but we're scientists. We are in a lab. We close the box. We put in one thing, one drop of government spending, and see how it reacts. And then you have the marginal effect of that particular type of shock. That's often not the case, right? It's a little government spending, it's a little consumer confidence, lots of things dropping in at the same time. So that's what we're going to try to do. Specifically, our structural model is hit simultaneously with four demand shocks, and we're going to hit them on the structural parts of the model, GNX C0I1. Now, at this stage of training, you should have a good sense of what those mean. If you don't remember, scooch over here. You have the reduced form setting up at the top with the ISMP Phillips curve, and then some structural components of government spending. That doesn't mean that's the entirety of our structural model, right? Inflation could be broken out into its subcomponents, interest rates by tenor, etc. But this is just bits and pieces for our purpose. So we want to hit those four things simultaneously. I didn't tell you which direction. I didn't tell you how much. That's what you have to find. And how do you find it? Well, let's be a little bit more specific. I want you to find the size of the shocks such that whatever the model does, its output is going to match what we observe in reality. All right, so you're going to hit these things until the model matches what you see in reality. But there's lots of different ways to think about parts of the model. So let's be specific. I want you to use the rescaled contributions to GDP growth for each component matched to the contribution seen in Table 2 from the GDP report for 2020, the year 2024. And then I give a little clause about the ease. Let's just think of time periods as years. Now, before we even go to the question, there's a few bits and pieces there. Let's take a look at the template so you understand some of these bits and pieces. Rescaled, contributions, GDP, and the BEA. All right, I'm going to scooch over and up and out. You see the breadth of everything that we have here, and you've played with this template before. Just make sure you're comfortable with what's going on. Here we have time period T minus 1, time period T, the changes and the percent changes. Every time you move something, there's going to be a change in yellow. That's just to indicate that something is different. We got the parameter shocks, exogenous equilibria. I'm a nice guy. I gave you all those formulas already. Star variables, and then a bunch of structural parameters. So what we have up top is reduced form. What we have on the bottom are some structural aspects. And then what we do over here is we scale. Don't forget when we were trying to make our reduced form match talk look like our structural model, we want to avoid the issues where structurally C plus I plus G plus NX doesn't match Y from the reduced form model. So all we do is scale it by that amount. All right, you got that same thing in period T, and then you can take a look at if we have some types of shocks on the IS or the PC and a four equation system. That would also be for maybe OL or monetary policy. From this, then, don't forget that just connects to the reduced form, imputing and inducing some structural values for C, I, G, and X. And we can look at their changes and their shares. And don't forget the shares are just like a fraction of the total. And then the growth contribution. You're multiplying the percentage change in the share. So what this is suggesting, don't forget, this isn't the first time that we've done this, but the contribution to a total growth, you have Y. Think of it like a bar chart, right? And you have it broken up into pieces. It's a stacked bar. How much did each piece, C, I, G, and X, contribute to growth? Well, how fast did it grow? How fast did I or G or NX grow? And how important is it? We could have something, let's say it's net exports, growing really fast, but it's a small fraction of overall economic activity. So it won't have as big of a contribution to that growth. When you take all those contributions and you add them up, it should be equal to the total GDP growth that we see in the C plus I plus G plus NX structural, as well as the reduced form. We want to make sure that they match. So I use the rescaled values. That's going to take the induced structural times our scalar and then repeat that whole process. Okay, go back down to the question. Why did I go through that process? Because the question's asking you for the contributions. Which contributions? The rescale that I just showed you. So that means that what we're trying to do is set these things here to be targets. Okay, so I want to make those move until it matches something. It matches what? Table 2 from the BEA's GDP report. All right, so we know the GDP report. Let me go. There we go for the BEA.gov. Um, what have we done? What have we done in class? What have we done on the videos? We always want to be cognizant of the fact that there's changes, improvements, re-estimations of GDP reports. So we always want to include and use the most recent one. You could click over here, and if you remember, you go to related materials, you can get the PDF, and let me scooch all the way up to the top. And the setup, the last one, right now it's December 9. It hasn't been since September. Why is that? Government shutdown. We'll be having more soon. So that was for the second quarter. That's what we're going to use because that's the best practice always for the ones that are the most recent. All right, keep on going. And table 1 gives you rates of change. And the most recent rate of change was 3.8. And then there's 2.5 for personal consumption expenditures. That's the C. But it asked for, forgive me for going back and forth here, it asked for table 2, the contributions. So it's not the rate of change. Hopefully you didn't fall into that trap. Table 2, the contributions. All right, so we're using, as the standard goes, the most recent estimations, and we're using table 2, which is for contributions. For what period? The instruction said the year 2024. All right, so we got 2 for personal consumption expenditures. You take a look at the total growth over that period of 2024. Top line right there says 2.8. So 2 percentage points of that, a lot of that was just due to the consumer. Scooch on down and you get 0.54 to investment. You get minus 0.39 for net exports, negative. And then you get government spending 0.65. So we have what it is that I need to move. We now have our targets in place, and then we have to figure out what are the variables that I change in order to accomplish that. Well, those are the shocks, the G, the NX, the C0, I1. I highlighted them here for you in blue. The C0, the I1, the G, and the NX. We can think about what each of these pieces of the puzzle mean. Let's start with the C0. We've talked about consumption functions before. I even draw one, write one out for you right there. C0 is kind of like an intercept in a consumption and disposable income space, and it kicks it up. So what we're saying is for any given level of disposable income, any given level of interest rate, the level of consumption is higher. Maybe more consumer sentiment, right? Maybe people are just more confident that they want to be able to buy more stuff. Possibility, lots of different possibilities for that. I1. And if you remember the way that goes, I is I1 minus I2R. Both of those are parameters. In fact, the C0, C1, C2 are parameters. And again, it's kind of like an intercept. The I1, if it's investment and the interest rate, I1 is part of that intercept. And if we raise I1, it's kicking up. So for any given level of interest rate, investment is higher. Before we talked about consumer confidence. Now it could be business confidence or some type of tax law change or whatever it might be. Government spending, we know how to capture that, right? Defense, non-defense, etc. We're going to assume that's entirely exogenous, so we're just moving up in any given part. We could break that up into further structural pieces. Not doing that right now. And net X, again, we could break that up into further structural pieces. We're not doing that right now. So those are the elements that we need to move. And we move them until these contributions match. Where are you? Where are you? Sorry, flipped screens. Until those match, they should have been a lot more dramatic. Match table two from the contributions. All right. So let's skip away from the template and look at the solution doc. Look up here, right? Homework for solutions. So it turns out that we'll have a 16% increase in C0, a 3.8% increase in I1, increase in G, and a decrease in net exports. All of that will allow us to have C, I, G, and X match our targets. Okay, so how did I do that? Well, first thing we want to do, create some squared errors. Take what your model says, column S, subtract off what your target is, column T, square them up. Now, since you're squaring, the order doesn't really make a difference. And then we're going to add those up. Square them up and add them up. Usually what we do is we set U7 as our target, the sum of the squared errors. But in the instructions, I asked you to go a step further. What I asked you to do was to do something like that. I'm taking the squared error, multiplying by the share. In the instructions, if you saw in the orange text that I gave you a couple minutes ago, it said to multiply weighted by the T minus one rescaled share. Why would I ask you to do that? Well, we know C, I, G, and X are not equal partners in the GDP dance. Let's see if I have a graph that can help you show that. Take a look at the pie charts. The blue is consumption. It's huge compared to the others. It's more than half of economic activity in our model specification. And in fact, in reality, for the US economy, it's even more than that. It's like 60, 70%. So when I'm thinking about trying to fit and calibrate all the shocks to economic activity, and I'm looking at these contributions, I want to ensure that I'm giving more weight to the consumer. Now, is that really necessary? Well, my contributions already have, don't forget, a bit of a share in there. So is it really necessary to do that? Probably not. I would love to hear if you can make arguments for and against it. That really shows me that you're thinking. But the basic motivation is that we're trying to ensure through our calibration that the bigger pieces of the pie are more important. And then I would add those up. So what I would do is I would do a simulator, pardon me, I would do the solver. I would set my objective function equal to V7. And I'll show you what that looks like. Solver. V7. I want to set that to be my objective function. What do I want to do to it? I want to minimize that. And what cells do I want to change? B63 to B66. Let me close this for a moment. I want to show you where those are. B, what the world are these down here? Right? Like, where do those things come from? That's not part of the G and X. All that stuff is up above. That has nothing to do with the macro model. This has to do with the way Excel's solver works. When you're using that solver, the variables that you're changing have to be contiguous, up or down. They have to be close to one another. I want to change C0, I1, G, and X. They are not contiguous. And in fact, let me click on one of these. Where does that go? That goes down here. So all I did was make a link between them. And then I use these as the variables that I'm going to change. Every time you change one of these, it changes the structural values. All right. So that's why the by changing variable cells is B63 to B66. I also added on a couple of constraints. I set two of them to be greater than or equal to 0. Now, why did I do that? Well, we know that all the parameters in our model, and in fact, I'm going to show you the model summary. Anything that you see on here that's a parameter, the alpha, the beta, the delta, they're all defined to be from us colloquially as non-negative. So I wanted to make sure that my solver knew that these bits and pieces here were non-negative. You could make an argument, well, G and NX, those should be non-negative because they're economic activity. Two things. One, they're real. So you could think with inflation adjustment, maybe they're not always positive. And two, net exports is negative. So you have a strong basis for why I should restrict these two. And in fact, you could try to make an argument, oh, well, they're a companion, right? C0 is inside of C. So if C0 is positive, that must mean that C is positive. Likely, technically not necessary, but likely. But the stronger point to be consistent with our model structure or that the parameters are non-negative. Okay, so I would then go back to over here, go to solver, call that up, and you just hit solve. And then what that would do, it was try all these different combinations of these bad boys right over here. And what that would do is it would change these over here, which would change the values in column C. And I can illustrate that in yellow, right? Remember, we said before, anytime column B is different than column C, the differences are highlighted in yellow. So we have the size of the shocks. We have that C0 went up by 16, 3.8 for investment, G, and then X respectively. Sounds like you're done, right? You're not quite done. Okay, so let's think about this. Again, this is the difference between reduced form and structural, theoretical as well as we're talking empirical. If all I did was change these values here, and here, and here, and here, none of that would impact my reduced form model. Don't forget when we first introduced the notion of structural modeling, the way that we approach it is we can start a reduced form, get a sense of Y, I, R, and just let that dictate, or which we call induced economic activity at its structural level. But if we wanted to do what we were doing here, where we're starting at the structural components, we want to see how it impacts economic activity at the reduced form, we needed to connect them. So how do we connect them? C0, I1, G, and X are all going to be on the demand side. So what equation in our model captures the demand side? That's going to be IS. So we have an IS shock, epsilon IS shock. What we need to do is take all of those four moving pieces and summarize their movements into epsilon IS. That's what we do right here. D41443037. Adding up the changes in C0, I1, G, and X. I don't know if it's exactly in that respective order, but you can see it highlighted right here. We're adding up all those changes, all of those deltas. That should give you the size of the shock. Almost, almost. Did you notice I multiplied by B48? What was B48? That was the multiplier. the way to move from structural to reduced form. So I have a bunch of these structural shocks. I want to multiply by the reduced form divided by structural. You can think of it almost like the units of structural canceling out. And that leaves you with epsilon is. That leaves you with this reduced form amount of the shock. Once that happens, well, then, not only does y move, but pi moves, r moves. Okay, so that's the empirical. Let's think about sort of a little bit more intuitively what happened. We have this confluence of structural shocks that are all on the demand side. So you could think of it visually as the IS curve kicking out, right? That's a positive number movement. So the IS curve kicking out. And when that happens, there's immediately a rush of economic activity. And you see that with an increase, not necessarily 2.8, okay, because let me tell the rest of the story. As you get more economic activity, then you see more inflation vis-a-vis a Phillips curve. See more inflation, then you see higher interest rates vis-a-vis the monetary policy role. And higher interest rates starts to quell some of that increase in economic activity and output. And that goes round and round until you get to these final resting points, the equilibria that you see here, or that you see here, or the way that it's induced over here. On the left, what you see are the compositions of growth and of economic activity, pardon me. And then on the right is a stacked bar chart to that total of economic activity after that shock. Okay, so sounds like we're all good, right? But there's this other graph here called nominal interest rates. They went up. Why did they go up? Well, remember nominal and real. What's the difference between nominal and real? Sounds like a bad joke starting off, but it's inflation or inflation expectations. Here I did it on inflation. You could very well do it on inflation expectations as well. Um, and what we're going to do is take the nominal and say, well, that's equal to r plus pi. And that allows you to figure out what the Fed must have done. Remember, our model is about R. Our model is about real economic activity and real interest rates, and the Monetary Policy Authority is in our model setting real interest rates. But we know in practice what that does is actually influences economic activity, borrowing and lending at a nominal rate. The Federal Reserve actually targets and sets a nominal interest rate. That's the one that they announce. And they kind of, or the way that we interpret it is we back into a real interest rate. Our model starts with the real interest rate, and we'll use pi and R to figure out what that nominal interest rate I must have been. So why did that thing go up? Well, in our story, it went up for a couple of reasons. One reason, uh, R went up. Monetary Policy Authority saw higher inflation, so it went up. Second reason, well, inflation went up. That was the reason for which the Fed moved. So both pieces of the nominal interest rate went up, which meant that that nominal interest rate went up quite a bit, 63%. Now, is that realistic? You know, we could talk about the calibration, but that's what happened. And as a result, we had a movement in the nominal interest rate. Now, the last question that I posed to you, I think that was the last question, is going to be about, let's see over here. Make sure we got everything right. We got all the bits and pieces about what moved. Let me scooch this over so you can see more. How did we include it? What were the constraints? What's the purpose of weighting? What's the direction of the nominal? And then how would real rates have responded to the shock if alpha was higher? Intuitive explanation. We could do some math. We could do empirical, or here I just wanted intuition. So for that, let's go back to the model summary right there. First equation, alpha is inside of the IS curve. Remember, whenever you're thinking about the meaning interpretation of one of these parameters, if you're a calc person, take a partial derivative. Y with respect to the interest rate gap. If you're not, just, whatever is the variable next to that parameter, what happens to the one on the left? So if I move that interest rate gap up one, y, which is our target variable, is going to move by alpha. Now, how much? Up or down? Well, we can say up or down. We see there's a negative sign there, right? So that means that as the interest rate gap moves up, output's going to move down. That's what the negative sign means. From the graph, pardon me, well, actually from the graph, but from the equation, you can't tell how much. That's why our empirical model in Excel is so helpful. But from the intuition, what's happening? We get hit with this demand side shock. Output pushes up, IS curve pushes out. Phillips curve kind of smells that. Inflation starts to rise, so the Fed reacts and they increase interest rates. People who are going to borrow homes, cars, etc., they start cutting back on economic activity as a result. That process continues. Now, what if alpha was higher? Well, that means that last step in the process where people see that the Fed increased interest rates and they start cutting back on their borrowing and economic activity. That's more violent. So, this last question, how would real rates have responded if alpha was higher? Same shock, but just intuition. Alpha captures that sensitivity. People would be more sensitive, so they would react a little bit more violently. And in our case, what that means is that economic activity would be quelled more than otherwise. All right, my friends, lots there. Hope that helps. Good luck.